Hello, my name is Mason Dana, and today I'll be presenting my Bioinformatics final presentation that I did along with Christina Fennell. So we were looking into this gene called SOX4, which is a transcription factor that allows for normal embryonic development. So when SOX4 is mutated, it can cause degenerative disorders and possibly cancer. And the data that we collected came from exploring the impact of the wild type transcription factor for SOX4 and a mutated version of SOX4 within mice. So for our methods, we first downloaded all of the data from the NCBI website and imported it into RStudio so that we could analyze it. Then we used the numerical data that was extracted to do some more analytical searches. So we found the means of SOX4 wild type data and the CKO mutant data, and we calculated it and created box plots to determine the distribution of the data. Correlations between the wild type and mutant genes were also determined to explore the similarities between the genes. We also did a t-test between the wild type and mutant genes to determine the p-values and the significance of the data. And then we created histograms and density curves to analyze the distribution of the p-values and q-values to verify that significance. So here are our results. So this figure shows a box plot of each sample that we analyze in the data. And because the data has been normalized, the box plots look very similar, as you can see. So this is the distribution of the gene data. So here we have all of the wild type mice and the mutant mice. And then these are the data that were used to create the histogram in the previous slide. So here's a correlation of wild type and mutant genes. So here we did a correlation between each gene against the other. So here we have wild type 20 against all of the other genes and so on. And here we see that the difference between all of the genes is very little. So the biggest difference that I think we see here is 0.989, so not very much difference there. This histogram shows the p-value frequency distribution among the different genes in our set. And here you can see that most of these p-values lie between 0.1 and 0.2, showing that not very much is significant. So this is a histogram plot of the q-values that we found, and we see that most of the q-values are around 0.6. This is our distribution of q-values, and so here we see our min, median, mean, mode, and max, and this was used to create the histogram. So here are significant p-values. So here are all of the genes that had a p-value of around 0.05. So there are just two, and we analyzed just the first 50 lines of data out of about 15,000. So this is just a really small glimpse of the significance. But again, out of 50, we only found two, so not very many p-values were coming up showing significance between the data. So the significance of the p-values demonstrates that the SOX4 transcription factors does play an important role in the normal organismal development. And further future analysis on other developmental genes along with SOX4 can ultimately help regulate human development in the future. Here are our references. Thank you so much for listening to me and taking time to watch this video. Have a great day.